Properties of exponents and roots and radicals in Algebra 2. So this first part is dealing with your rules of exponents, which you learned in Algebra 1. So it's going to be kind of a quick review for you. I'm going to leave this third column over here for notes for you to take any reminders that you want to jot down and just have to reference through this unit. Just make sure to pause the video so you don't get lost with the rest of it. I'm going to focus mainly on the property and the example. So in this first one, I'm multiplying two bases that are the same, and the base is the letter A. It's the thing with the exponent. So my bases are the same, and I'm multiplying them. This property tells me that I'm really just going to end up adding my exponents. So in my example, I have x squared times x to the fifth. My base is the same, which is x, so that's going to stay the same. And so now I just have to add my exponents, which just means 2 plus 5. So my final answer is x to the 7th. And if you need to, pause the video, jot down any notes. In this second property, I'm dealing with parentheses. So that's a big difference between the first and the second one. First one, there were no parentheses. The second one, I'm dealing with parentheses. So what that is saying is I'm now taking something, so a to the b power, and I'm raising all of that to the c power. And what I want you to remember is that when you see parentheses, think distributive property. So that might be a note to write down. Distributive property. So here we're going to end up multiplying. So a to the b raised to the c power is going to give me a to the b times c. In this second part down here, notice there are two different things inside my parentheses. I have the number 2 and I have a. Distributive property, you distribute to everybody. So after I do that, it becomes 2 to the c power and then still a to the b times c. And then we're going to simplify from there. So if I look at my examples on this top one, I have x to the 4th raised to the 3rd power, which is going to give me x to the 4th times 3, which will really give me x to the 12th. In the second part of this example, I have a number inside. I have to distribute to everybody. So that means I'm going to have 3 squared and y to the 5 times 2. 3 squared is 9. We always want to simplify as much as we can. Then we have y to the 5 times 2, which is y to the 10th. The 0 property should be everyone's favorite because anything raised to the 0 power is 1. So x to the 0 just equals 1. Big thing here is that negative exponents are not allowed. So I might want to write that. Negative exponents not allowed. So in order to do that, you think of the fraction bar as the place where they switch. So if the exponent is negative on the top, it becomes positive on the bottom. And if it is negative on the bottom, it becomes positive on the top. But you only move it if it's negative. You don't always switch both. So you only move the negative one. So in this case, in my example, I have x to the negative 4th on top over y to the positive 3. That means this x to the negative 4th needs to come to the bottom. So I have x to the positive 4 on the bottom. Y to the 3rd is already positive, so that's going to stay on the bottom. Now that means there's nothing on top, so we need the number 1 as a placeholder. So I might make another note, only move the negative ones. So we leave positive exponents alone. Now, the last two we look at if both are already positive and we're dividing. Notice that they are the same base. When this happens, we subtract. So, in my example, both are x's, same base, and it's always the top number minus the bottom number. So this is going to become x to the 7 minus 3, which gives me x to the 4th. So again, same base, subtract when you are dividing. And then notice here we have parentheses again. And parentheses means distribute. And when we distribute, we multiply. So that would become a to the b times x and d to the c times x. So in my example, I have x to the 4th times 2 over y to the 3rd times 2, which gives me x to the 8th over y to the 6th. In this case, I'm done because my bases are different, so that's all I can do. So again, that was a quick overview of your exponent rules. You will have to memorize these and you will have to know them by heart for your test. Now let's do a quick review of simplifying radicals. Remember, radical is this root sign. So in this case, this is our square root. So in order to simplify this, we need 2 of a kind. So 2 of the same to come outside, because it is a square root. Here, because we have this 3, in these cases, we need 3 of the same. And I'm sure you can guess what the 4 will tell us, that we need 4 of the same. So I'm going to do an example of each. I'm going to start by breaking down my number. So 8, that can be broken down to 4 times 2. And then 4 can be broken down to 2 times 2. So because it is a square root, I need 2 of the same, which I have. So that group I circled is now going outside. I'm going to leave some space. Square root of, I still have this 2 left inside because it was not circled. Underneath the square root sign, I also have 4 x's. So I'm going to draw out 4. And remember, because it's a square root, I need 2 of the same. So there's a group, and there's a group. So that now means on the outside I have x, and I'm going to put the squared because that means I have 2 groups. I don't have to write any x's underneath the square root sign because all of them were taken to the outside. And I also have 5 y's. So I'm going to draw out 5 y's and circle my groups. So 1, 2. So y comes out, giving it an exponent because that means there are 2 groups that I circled, and I still have this y left over. So that is completely simplified for this first example. All right, let's look at example 2. So example 2, I'm taking the cube root. Cube root means I need 3 of the same. So I'm going to start by breaking down 27. That can be broken down to 3 times 9. And then 9 can be broken down to 3 times 3. This now gives me 3 of the same. So 3 comes to the outside, just one group. I'm going to leave some space. And I need the cube root still there for the rest of my letters. Notice I put the 3 with the cube root. That's really important. right, so now let's look at my letters. I have 5 x's, so I'm going to draw that out. Remember, I need 3 of the same. Okay, so that means I have one group on the outside. I don't need to write the exponent of 1. Then I have 2 x's still inside. And anything that is not circled, we multiply. So x times x gives us x squared still underneath. We have 3 y's, so I'm going to draw that out. So one group comes to the outside. There's nothing left over. And then 2 z's. Well, 2 isn't enough. So no z's come to the outside, which means I'm still left with z squared inside. And finally, example 3, we're taking the 4th root, which means I need 4 of the same. So again, I'm going to start with my number. So 16 I can break down to 2 times 8. 8 I can break down to 2 times 4. And that 4 can be broken down to 2 times 2. So there are 4 of the same numbers. So that means one group of 2's is coming to the outside. I'm going to leave some space and write my 4th root. No numbers are left over, but I'm pretty sure I'll have some letters. So x to the 3rd, I'm drawing out 3 x's. But here I need 4 of the same, which I don't have enough. So we're leaving it as x to the 3rd. Then I have 5 y's. And again, I need 4 of the same. So that gives me one group of y's on the outside, and I still have 1 y that wasn't circled. And then 8 z's. So 1, 2, 3, 4, 5, 6, 7, 8. So again, 4 in a group. So there's one group, 2 groups. So z, and then I'm giving it a squared because of the 2 groups. All of the z's came outside, so I have nothing left inside. The big key to remember with these square roots and these cube roots and 4th roots is to write the little number so we know what kind of root we are taking.